Welcome, ladies and gentlemen. I'm V.S. Subramanian, and I'm the director of the Institute for Security, Technology, and Society at Dartmouth College. I'd like to welcome you to this event that is co-organized with the Ethics Institute at Dartmouth. It's my very great pleasure and honor to introduce as our distinguished speaker for the day, Francesca Rossi. Francesca is an IBM Fellow and is the Ethics Global Leader for AI Ethics for IBM. She works at the T.J. Watson IBM Research Lab in Yorktown Heights, New York. And prior to joining IBM, she worked as a full professor of computer science at the University of Padova in Italy. I think Francesca has a very long and distinguished history in computer science. But I would like to just say a few words. I've known Francesca for at least 25 years, maybe even 30. And she has been one of the leaders in virtually every area of AI that she has worked in. She's published over 200 scientific papers in the top journals and conferences in the field. She's an elected fellow both of the biggest artificial intelligence professionals association called the Association for the Advancement of Artificial Intelligence, as well as the European version of the same association. She's been the head or president of the biggest AI conferences and has served as the editor-in-chief of the Journal of AI Research, one of the top journals in the field. She is one of the leaders over the last several years, has emerged as one of the biggest leaders in the ethical aspects of AI, how we might consider, how we should consider ethics when developing AI systems so that while trying perhaps to do good, we don't inadvertently compromise the human rights or privacy or other aspects of individuals. She's on the executive committee of the IEEE Global Initiative on Ethical Considerations on the Development of Autonomous and Intelligent Systems. She's also the member of a very large group of industry, government, and academic organizations called the Partnership on AI. She's a member of the board of that. And she's been a member of the European Commission's high-level expert group on AI and the chair of several major AI conferences. She's the president-elect of the Association for the Advancement of AI, starting from 2022. So that basically means that she's probably working on it quite a bit even today. So without further ado, it's my very great pleasure once again to hand the mic over to Francesca. But before I do that, I'd like to ask everybody to please make sure you're on mute. You're welcome to ask questions through chat. And the way this session is going to proceed, Francesca is going to talk for a while. Then the two moderators, myself and Sonu Bedi, who's the head of the Ethics Institute, will have a discussion with her for about 15 minutes, and then we'll turn the floor open for questions. I should remind all participants in this meeting that it is being recorded. So please keep that in mind. And by participating, we assume you consent to that. So without further ado, Francesca, over to you.
Thank you, V.S., and thanks for the opportunity to speak at the Dartmouth College. So I'm very happy to be here, although, I mean, unfortunately, I cannot be there in person, but hopefully, soon we can do that. So let me share my screen so that you can see my presentation. Okay, can you see that? Yes, right. So, okay, so today I'm going to give a non-technical talk about AI ethics to understand what is this field, why there is so much activity around the notion of AI ethics, and what is the right kind of activity that is needed to actually address the issues that are considered in AI ethics. So let me start with just a brief history of AI, because some of the specificities of the AI techniques are going to be driving some of the AI ethics activities and principles that have been put together. So, of course, as you know, AI has been around for a long time, but for several decades, it was mostly machines were intelligent in some, quote unquote intelligent, so the machines knew how to solve problems because there was a human being that understood how to solve a problem and then coded that algorithm into a machine. And these worked well for problems where the input was very clear and very and we didn't need any flexibility. We didn't need too much uncertainty in the definition of the input. Then other techniques came about in the 80s, mainly, based on this idea of machine learning, which was fundamentally different. So instead of writing down exactly the steps that are needed to solve a problem, we are going to give a machine in one incarnation of machine learning, we're going to give a machine a lot of examples of problems and solution to the problem. And then we let the machine extrapolate and generalize for these examples so that the machine then becomes able to solve the problem even when it sees a situation that has never encountered before. So these techniques are very widely used now. But the other ones, as it shows in my visual, they're still used, and actually most of the AI systems are actually using also the other kind of techniques that you may call symbolic, logic-based, and so on. But to understand that AI has a lot of combinations of various techniques. So let me give you a little bit more details about these two main line of techniques, the ones that are, where the algorithms are defined by human beings and coded by machine, and which is usually called symbolic or logic-based, rule-based AI, and the machine learning one. So for symbolic rule-based AI, the example that sometimes I give is of the algorithm that is used, for example, by your GPS, by your Google Maps or whatever, to find the best route from where you are to where you want to go on a map. So in that case, the input to the algorithm is the map of the various streets, is the places where you are, where you may want to go, and so on. So the whole map, and the algorithm has to be as smart as possible to find the shortest route, for example. And this is usually done with some version of this algorithm that has been around for a very long time, the A-star algorithm that you find in every textbook of AI. And this works very well in this kind of algorithms work very well in these kind of problems, meaning that problems where the input, which is the map and where you are, and the output is where you want to and where you want to go. That's the part of the input, and the output is well defined, which is the one route between where you are and where you want to go on the map. So there is nothing uncertain here. Of course, you can have many other versions that take into account the traffic data and go on, but in the basic one, everything is very clear. So this is the input, this is the output that you want, and you are sure that with this algorithm you have certainty of correctness and of optimality. You're sure that the algorithm and this very efficient algorithm to find the optimal solution. Of course, this is, again, works well in this kind of problem. The input and the output is very clear. So let's look at the machine learning problems, and let's look at this example. So in this example, you see this picture like of a neural net. It doesn't matter how, the picture, that's a prototypical picture of a neural net where the balls are the neurons of the net and the lines are the connections between these different neurons. And one neuron is just a very small computation unit that implements a very, very simple function, and then they are all they're connected with each other in some way. So in this example, this neural net has in input an image of an animal, and in output in output, it has the classification of the animal that is represented in the image. So the possible outputs here are cat, dog, horse, or monkey, assuming that these are the only animals in the example that we receive as input. So what happens with these algorithms that you give a lot of examples of images, and for each image you give the correct classification. So if I give an image of the horse in this case, and I also give it the correct classification, the horse, or also for the other images, and this is and I give this information as a training data. So the network, the neural net, is going to learn in some sense from these examples and their labels and the correct classification, in order to be able to perform well that task also in images that has never seen before. And so what happens is that you give this and you see whether it responds correctly or not. So for example, here I gave an image of a horse and he classified it as a monkey, so there is an error. So then given this error, the network is going to update its connection and weights, whatever the internal parameters, to make sure that the error in classification is as small as possible. And how do I test this error? I test it on another data set of images where I check whether it makes the error or not. And when I'm happy with the accuracy of the network, then it's ready to be deployed, right? So this is a fundamentally different. And why do I need to use these techniques? Because for these kind of problems, for example, to recognize animals out of these images, I would not be able to write down a precise sequence of steps that assures me correctness, or at least assures me to be as correct as the neural net, starting from images. Because in the image of a dog, for example, and you see 2 or 3 of them here, you can have dogs that are very different, that are from very different angles. So you would not be able to write down a precise set of steps that, given an image, it assures you that at the end you have the right classification. But with machine learning, which is probability based and statistic based, then you can be correct with a very high accuracy in many situations. So machine learning, in some sense, as a complementary pros and cons with respect to the symbolic rule-based AI, because it's much more flexible. It's also accurate, usually for problems that are not very well defined, like image interpretation or text interpretation, or understanding of the vocal commands to our telephone or Alexa or whoever other AI system. But it has several limitations. First of all, it needs a lot of data in order to perform well, and therefore also a lot of computing power. Also, by telling the machine what to do in this indirect way, not telling the machine exactly what to do, but through examples, we lose control in some sense to what the machine is actually going to do. So it's not easy to understand how the machine gets to the output given the input, because we don't have really a clear visibility of the steps that the machine is taking to go from the input to the output. So it has pros and cons that are more or less, complementary to the other. But both of them are useful, especially when you want to have the ability to perceive what is in the real world, because as you see here in this example, the machine was able, in that example, to interpret correctly what is in an image. So it was able, in some sense, to have perceptual capability about seeing or reading, or which is not correct to use these words for machine, but I mean to anthropomorphizing, but that's the idea. With these capabilities, the machine can be more aware of what is around the AI system in order to behave in the best way to solve a problem. So let me give you here some of the applications that we worked on at IBM that span many different sectors, from healthcare to manufacturing to customer care to media to marketing and so on, to IoT. So there are many different applications, but these are just some of the applications that we address at IBM, and IBM only connects to some kind of AI, some way of AI, because the IBM business model is that we deliver AI not to single individuals, but to other companies that then use our AI solutions to do whatever they need to do in their operations. But of course, there are many other companies that have a different business model that deliver AI directly to individuals. So, and that's the kind of AI, in some sense, that single individuals see more in their life, like digital assistants, self-driving cars, everything about the social media, or even web search, some healthcare, also in the financial domain, credit risk scoring, client service chatbots, resume prioritization, and so on. So, as you can see, most of the things that we do in our daily life are supported by some AI technique, whether it's rule-based or machine learning or a combination of the two, but really AI is becoming very, very pervasive in our life. So, but AI is not done yet. It still has a lot of limitations, of course. Limitations due to the fact that still AI, no matter how much data and how many resources or computing power we put in place, still AI falls short on several aspects, like in terms of generalizability, abstraction, robustness, as well explainability, to explain why it's making certain things, as well as we need still to understand how to address completely some of the societal impact things. So here you see a picture of AI, like in a self-driving car that has to make, resolve a dilemma about whether to go through, towards a wall or to run over some people or cats or dogs or whatever. Other ones that shows that the stop sign thing, it shows that the AI is not robust because in some cases, even a small perturbation of an image can generate a completely different classification. Like in this case, you see a stop sign that 99% of the time, 99% confidence is classified correctly as a stop sign, but the other stop sign that we would be in no problem recognizing it again as a stop sign, even if there is something on top, is still instead here with 80% confidence to recognize as something completely different, a sports ball. So AI is not yet done. And also there are a lot of issues around, which is the main topic of the talk, around the ethical implications in using AI and deploying AI in the real world. So let me see here what I envision as the future of AI, but also with AI, because in my view, the future of AI is in supporting human beings in making better decisions rather than going on its own way by itself, autonomously. And so, but of course, it still lacks generality, the ability to solve many different problems and to adapt to new environments, something that we human beings know how to do, but AI still doesn't know. Is very focused, is so-called narrow AI instead of general. To be working with human beings, AI should be trustworthy, so it should be reliable, it should be explainable, it should be not biased, compliant with whatever are the ethical principles for that scenario where the decision need to be made. It also has to be able to work well with humans. So effective human-machine teaming, what is that needed? There are a lot of, for example, question answering systems, but there is no yet dialogue system, because we don't know, AI still doesn't know how to sustain a dialogue with a person. And of course, without a dialogue with a person, it's difficult to have an effective human-machine team. And also, AI needs huge amounts of data to perform well in some situations. For example, just think of the recent GPT-3 model that is very good at finding correlation in text data, so to generate new text that makes sense as a continuation of a text that a human being can write. But it really needs a lot of data, a lot of computing power. And so it is while we human beings can learn to do a new task with little data. So why isn't AI being able to do that with little data as well? Because of course it cannot reuse information and knowledge from other problems. So AI ethics is something that is recently really being very a subject of a lot of activities, both by researchers and companies and the governments, the media, and so on. And this is shown by this graph, where in the past few years, really starting in 2017 mostly, this talking about AI ethics really became very, very prominent in many areas. So what is AI ethics? AI ethics is kind of a multidisciplinary field of study, not just AI experts, but also philosophers, psychologists, lawyers, sociologists, policymakers, and so on, that has the goal to understand how to design and build AI in a way that when deployed, this AI is aware of our values and knows how to follow these values and does not go into directions that are undesired and unintended. So the overall goal is says, how do we optimize the beneficial impact of AI? Because of course we all are aware of many useful and beneficial impact of AI, while at the same time identifying the risks and addressing them. And this is done within this multidisciplinary field of study by putting forward both technical solutions, but technical solutions are not the end of it, cannot solve everything. So also non-technical solutions like standards, laws, auditing, best practices, guidelines, incentives, funding, so many other enablers that can drive the AI deployment and development in the right direction to be beneficial. So one can wonder what is specific about AI that needs this AI ethics discussion, which is so active. Why not ethics about any other technology? Of course, for any other technology, we need to make sure that is not misused, is not used in a negative way. So why isn't that what there is also about AI ethics? And in some sense, yes, of course, there are issues that are the same as for any other technology, but there are also issues that are specific to AI. By the way, because of the way AI techniques are functioning. So that's why I gave you an introduction of these AI techniques. So it's clear that AI needs a lot of data. In particular, when I say AI, the machine learning techniques need a lot of data to perform well. So, and usually, in order to provide solutions that are personalized, some of this data is private data, is personal data of people. So if you have a technology that needs a lot of data to function well, immediately the question arises about what happens to my data. What happens to the privacy of my data? Who is going to use this data? If I give it to a company for a personalized service, is that data going to end up somewhere else or not? So the issues about data privacy and governance are really very central to AI ethics. And there are some regions of the world, such as Europe, where there are explicit regulations that try to give explicit rights to the data subject. The data subject is the person releasing the data to an AI system. Second one is issues about explainability and transparency. So, as I said, these machine learning techniques are in some cases very successful, much more successful than the other kind of techniques, but they are kind of a black box. It's not really clear how they get to the solution from the input data. And if you have a black box, then it's difficult that you're going to trust this black box and make decision, allow him to make decision independently, or even if it's not making autonomous decision, but is suggesting decision to human beings, it's difficult that these human beings is going to follow this suggestion if he can't even understand how the AI system got to those recommendations or suggestions. So to avoid this black box thing really needs to be avoided because of this trust issue. And so issues of explainability. I would like AI to be able to explain why it gets to that solution or to that output, as well as transparency. So I would like to understand how AI was designed and how AI was, and we'll talk more about what transparency means. So we need to go over this black box thing. The third topic is about the kind of AI that makes autonomous decisions. So if I let this AI system to make an autonomous decision, I need to make sure, I need to be convinced that it can discriminate between good and bad decisions, and in particular decisions that follow some values that are appropriate for that scenario, and decisions that do not and should not be taken and should not be made in that scenario. So, for example, the issue of fairness and so unbiased decision is very important. So we want to make sure that these decisions that AI makes are not creating discrimination. The next is about the fact that machine learning is based on statistics and probability. So that means that the accuracy rate usually is very high, like, I don't know, 95 or even 98%, but there is always a small percentage of error. And not because some programmer made a mistake, but because it's in the nature of that. And if we had a technique that could assure that there is no error, we would use it, but we don't have it. So that's why we use these techniques that always have a small percentage of error, even if it's very small. So when this error occurs, so the machine makes a mistake, classify things in a wrong way or whatever, then it's important to understand the accountability. So who is accountable here? Because again, we need to understand that that's not related to a mistake made by some programmer. The next is about the fact that machines are using machine learning. They are very good at inferring correlations among data in huge amounts of data, much more than we are good at with our brain. So the AI can infer our preferences from the data that we convey, like the likes, the pictures, whatever we post on the web and so on, can infer our preferences even more explicitly than what we consciously can understand. And this can possibly be used in a negative way, like to manipulate our preferences. So that at some point, it may be that we are not really free in our own decision in a conscious way. So the questions of human and moral agency comes about. And the last one is that AI is very pervasive, as we mentioned earlier on, and is also changes very rapidly and invades our everyday life in a very fast way. So the fact that it's very pervasive means that if it is misused, the negative impact of the misuse is much larger than in any other technology. And also these fast transformations of the society and of jobs may not give us enough time to really reflect on the consequences and then take appropriate measures. So this is true, of course, for every technology, but the speed of AI is faster than in other technologies. So that may be more problematic to understand the impact and to address the possible negative impact on society and jobs. So this is a picture that shows that because of all these considerations, many different organizations wrote down a set of principles around the beneficial development and deployment of AI. So this is a visualization given by the Berkman Klein Center Cyber Law Clinic of Harvard. It's called the Principles AI Project, and it shows all the possible, well, most, I think that now is not really old because it's already in 2019, so I'm sure there are many new ones, sets of principles around AI. And they are all different, of course, as each set, but they have many things in common. So here I wrote the main themes that, as you see, are very similar to the ones that I mentioned in my previous slide. And this has been written by companies, by intergovernmental initiative, multi-stakeholder initiative, governments, civil society, but they all really look at from different angles with different nuances, but with all the same main themes. And so these are the main AI ethics issues. As I mentioned, data issues, fairness, inclusion, human and moral agency, value alignment, accountability, transparency, explainability, and the technology misuse. So how do we go from this very high, okay, we have identified these issues. Many people have written principles around these issues, but then is this the end of it? Well, no, it's just a starting point. Because if you are a company that produces AI, like for example at IBM, but many others as well, it is just the start of the journey of trying to understand how to get to the ultimate goal. And the ultimate goal, of course, is to understand how to deploy AI in a way that is beneficial. And these ethical issues are addressed. So so I would like to tell you a little bit more about our journey that started with some principles, but then we went on to define the issues, define the guidelines, define guidelines, toolkits, educational activities, coordination, enforcing activities, and many more. So here is the first step that we did, no? And this is true for many other companies. So first step in 2017, we said, what are our principles? And we called them the principle of trust and transparency. And we said, okay, first principle for us, the purpose of AI is not to replace human intelligence, but to augment human intelligence. So to be a supporting technology for human beings to make better decisions, more informed decisions in whatever scenario they need to make a decision. Second thing is the data policy. The data that we get from our clients, like from a hospital, from an airport, or from a bank, belongs to our client and is not shared to other clients or is not reused for solutions for other clients and so on. The third one is about transparency and explainability. And the reason for this emphasis on transparency and explainability is because we have this, as you see, the principle is about trust. So to achieve trust, we think that it cannot be achieved if the technology is not transparent and explainable. And without trust, we believe that the technology will not be adopted in a large scale. So we will not be able to get also the beneficial, impact of AI. So first step, the principles. Second step, we said, okay, these principles talk about trust, but what do we mean about trust? What do we mean to trust a decision made by a machine, besides given the obvious thing that it has to be very accurate and tested for accuracy and so on. And we spelled this trust out into 4 dimensions. One is fairness. We want to make sure the machine makes decisions that are not creating discrimination. Second one is explainability. We want people to understand why the machine made that decision. It cannot be a black box. Third one, robustness. We want to make sure that the machine does not degrade significantly with this very small change in the data distribution. And the fourth one is about transparency, which, conveying all the decisions that have been made during the development of that thing. So let me go a little bit more in detail about fairness. So fairness means the absence of fairness is basically, generated by this machine possibly being biased. And bias in general is a prejudice, for or against something. And if somebody is biased, then without maybe even being conscious about it, then one could behave unfairly to certain groups compared to other ones. So we know that humans are very biased. We have a lot of different forms of bias. And in this picture, you see a visual that represents all the possible kinds of biases that the humans have. So why should AI be biased? Well, because AI is trained by people, is programmed by people, and is trained on data provided by people. So if we are not careful enough, we are not conscious about our own bias, we can inject this bias into the data that then is used by the machine to learn how to solve a problem. So let me give you a simple example. So suppose you want to build a machine that can correctly understand whether a mortgage application has to be accepted or rejected. So, and assume that we use a machine learning approach, supervised machine learning approach. So we give a lot of examples to this machine to train it. And suppose by even without wanting, we, in this set of examples that we give the machine, all the women applications are to be rejected, not because they're women, but because the application itself does not have the right features to be accepted, and all the men applications are to be accepted in the examples. Not again, not because they are men, but because they have the right feature to be accepted. So if we give that set of examples to the machine, and then we let the machine learn from these examples, AI will identify this correlation between gender and acceptability that we were not even aware of, but we'll use that correlation in responding to any new application. So we'll see any new women application, and we'll immediately use that correlation to understand whether to accept it or not. So in that case, we have introduced a bias into the machine that will now behave in an unfair way, gender-based, not but maybe without even wanting, but just because we use this indirect way to tell the machine how to solve this problem. Let me give you another example of where the bias in the training data can show up in the decision made by the machine. Here, I use Google Translate. I took these two sentences in English: he is a nurse, she is a doctor, and I asked the system to translate it into Turkish. And the reason why I asked it to translate into Turkish is because by doing that, the system has lost the gender. Because you see it in Turkish, you have this big O in both sentences, so it's the same. So now the machine does not know the gender in the two sentences. And then once I got these two sentences in Turkish, I asked again the translation system to translate it to English. So now in that second step, the machine had to guess the gender. And of course, how did the machine guess the gender? So that the decision has to make the machine, and the machine guessed the gender from what it learns from the training data. So if the machine guessed she is a nurse and he is a doctor, it's because in the training data, the majority of nurses were in correlation with female, and the majority of doctors were in correlation with male. So that's how the machine made the decision of guessing the gender from information generalized and correlation found in the training data. Here you see many other examples of machines that have shown, of AI systems that have shown some bias. One on the left, top left, is a sentiment analysis that associates scores, positive or negative scores, to some features of a human being, like whether it's a Christian, a Jew, homosexual, and so on. The one on the bottom left is a famous example of image interpretation that tagged some humans as gorillas. And then on the right-hand side, you see the Amazon system that was shown to be unfair to women compared to men. The next one is the famous compass algorithm that was giving a score for the probability of somebody to reiterating or reoffending or redoing some other criminal activities. So a high score meant a very high probability of reoffending, a low score, very low probability. And it was found to be very biased, in this case, racially biased, because of course the system was making mistakes, and it was making the same amount of mistakes for Black and white people. So on a first one could say, oh, well, okay, so it's making the same amount of mistakes in black and white people, so it is fair, because yes, it's making mistakes, but the same amount. But then people went and looked more carefully at these mistakes. And of course, the mistakes can be of two kinds here. They can be false positive, so it gives you a high score, where instead it should give you a low score, or false negatives, it gives you a low score, but instead it should give you a high score. And then when you go and look with this lens about the false negative and false positives, people saw that, yes, the amount of mistakes for black and white people were the same, but for black people, it was giving mostly false positive. So it was giving a high score for black people, when instead it should have given a low score. And for white people, the mistakes were in the opposite direction. So it was giving a low score when he had to give a high score. So it was definitely treating, these mistakes were really different in a different direction for the two categories of people. The last chatbot example here is about a chatbot, a Twitter bot called Tay, that was deployed by Microsoft, and that was supposed to be just very engaging with the other people writing tweets. So it was supposed to respond to the other tweets in a way that was engaging with these tweets. And so it was in some sense evolving in its behavior given the data that was coming from the other tweets that it was reading. And because of this framing, this intention, in a few hours it became starting writing tweets that were very offensive, very xenophobic, and like this tweet that you see here. So after a few hours it was shut down. And so it was another example of an AI system that, given the data that was coming in, it was evolving and learning from the data that was coming in. So data is definitely one source of bias, but not the only one, but one source of bias for AI system. Let me give you a last example that involves IBM as well. So in 2017, somebody made an analysis of 3 gender classifiers. So these classifiers were taking an image of a person, face of a person, and we're trying to recognize the gender of that person. And here you see the 3 classifiers: Microsoft, Face++, and IBM. And in the red part, that's the important thing, is the error rate. And you see that, well, first of all, let me tell you what these columns are. So the people, the error rate was divided in various categories, depending on whether the image was the image of a female or male. So that's the F and the M, and whether it was dark-skinned or light-skinned. So D and L is dark-skinned and light-skinned. So you see here that the error rates are very different, and in particular for light-skinned male, is more or less very close to 0. So everything is done correctly, gender recognition. But for dark-skinned female, that's the first column, you see that the error rate can be very, very high. It goes from 23 to 36%. So again, these are a different of accuracy, different accuracy rate, depending here on the gender and also on the skin color. Then all these things were fixed, but again, this showed you that for many years, AI developers and researchers as well, they thought that the more data, the better. And they didn't think really that there were other features of the data that needed to be taken care of to make sure that this situation were not happening. So the next thing that we did in our journey through AI ethics is really to go from the principles, the dimensions of trust, but then to do a lot of research around bias, explainability, robustness, and so on, to develop a lot of educational material for our developers. So for example, this pink here is a booklet. It's called Everyday Ethics for AI, that is to make our developers, or any developer, because it's available for anybody, our developers more aware aware and more conscious of the bias, for example, that they can inject, of all the AI ethics issues that they can come up during the development pipeline, as well as also we developed a lot of toolkits. So these are two of them. One is called AI Explainability 360, and the other one AI Fairness 360, that address two main pillars of trust. And basically, these toolkits are open source, so everybody can contribute and can access what is there already. And they include code, data sets, guidelines, demos, tutorials, everything, so that the communities all together, the people involved, and in trying to understand how to address explainability or fairness, they can work together in this using these toolkits. One particular toolkit is about transparency. It's called the AI Fact Sheet 360, because this idea of the AI fact sheet is our way of saying how we think transparency should be handled. And so the AI fact sheet is just a long list of questions that developers should answer while they are designing and developing an AI system. And these questions are it's not just a checklist, but it's a question that makes developers more aware of what are the processes that they need to be putting in place in order to address in the right way all these AI ethics issues. So whether they need to add bias detection and mitigation algorithms, or all the places where they can add explainability measures and so on. So this is useful for developers as a self-assessment, but is also used for clients, for users, for possible auditors, third party that want to audit or to understand in what way this AI system has been developed. And of course, there may be different versions of different level of granularity and of details of this fact sheet for the different target audiences. The fourth thing that we are really devoting a lot of resources to is this idea of helping developers revise their usual AI pipeline in developing. Because, of course, you cannot just tell them, okay, these are the principles, these are the pillars, these are the toolkits, and then figure out how to revise. You have to define a very precise methodology for them. And not only that, you have to interact with them in a very complex and significant way to understand what are their challenges in adopting that methodologies and what their experience brings to maybe define a better methodology. So we have these three big areas of work, one about the methodology, one about the adoption to make it as easy as possible for them to adopt the methodology, and the third one is about governance, how you make sure that you measure the success of this adoption of that methodology, how you make sure you understand how to enforce the adoption of the methodology, and so on. And of course, in a company like IBM, the things are even more complex because we are very multicultural. IBM is in US, in Europe, in China, in India, and so on. So all these AI ethics issues may be spelled out slightly different ways because of the cultures. And the last thing that we do is, well, not the last one, but I mean, a very important thing is that, okay, at some point we said, okay, we have all these different activities in the various division, but we have to make sure that they are all coordinated and they are not overlapping with each other, and they're not redundant. We don't do redundant work, and we identify the gaps if there are gaps. So we put in place the internal AI ethics board with representatives from all the divisions of the company, with the mission of raising awareness, coordination, enforcing the methodologies that we define, but also to help not only developers to understand what to do, but also help the business units, the ones that are going to propose offerings to our clients, to understand whether an offering respects our principles or not. And so when the offerings have some AI ethics issue involved, they are brought to the attention of the board, and the board examines these possible offerings by looking at the properties of the technology, so whether it's fair, transparent, explainable, and so on. But then it also looks at the uses of the technology. What is the client going to do with this technology that we are delivering? And then as a third dimension, then it examines the client itself. So I've seen even recently, and of course, when this happened, the business units are not very happy about it, but I've seen very recently an offering that really the business unit was very excited about. And we really liked, the AI ethics board that I co-chair, we really liked the technology, we really liked the uses, but we did not like the client. We were not comfortable with the client. They did not have a good history of respecting human rights, privacy of people, and we decided to not deliver the technology. Having said that, the technology that they were putting together was very good, and so we encouraged them to propose it to other clients with whom we are more comfortable delivering that technology. So to say that is not just an issue about the technology, but also the uses and also the client itself. The other thing that we really spend a lot of time in is this external partnership. We believe that these issues around AI ethics can be addressed well and even identified well only together with all the voices that are around AI. So that's why we have all this partnership with academia, with other companies, even competitors, with governments, with civil society organizations, because only a multidisciplinary and multi-stakeholder approach can be successful in really even identifying the issues and then trying to understand how to address it. Let me say a few words about some of these initiatives. So one of them is the Partnership on AI that was started in 2017 by 6 companies. The main 6 tech companies, Amazon, Microsoft, Google, Facebook, IBM, and Apple. And these 6 companies decided that they needed some shared and collaborative space to discuss the AI ethics issues and understand what the best practices are in addressing them. But they didn't want to do that only within companies. They wanted to do that with many other stakeholders. And as of now, we have 100 partners. So partners here are not single individuals, but are either companies or UN agencies, university departments, or as research centers, civil society organizations. So these are partners, not single individuals. And all together, these partners, and right now, as of now, we have about 100 partners, of which about 20 are companies, and everybody else is all these other kinds of stakeholders. And we focus on these themes that you see here in the middle that more or less are very aligned with the AI ethics issue that I mentioned above. And for each one of these themes, we have several projects that have to do with the collection of use cases or lessons learned about explainability or recommendations for using AI into the judicial system, or so many different kinds of deliverables. The next partnership the next work that we did with other stakeholders is this example that we did with the European Commission. The European Commission in 2018 decided to put together a group of 52 people from many different stakeholders, representing many different stakeholders. It's called the High Level Expert Group on AI, where actually the AI experts out of 52 were less than 10. So everybody else was really coming from a different background. And this group put together 4 deliverables, which you can see here, the cover. It just finished the term in the last 2 years until the July of 2020. But the most influential deliverable is the first one, the blue one, which is the ethics guidelines for trustworthy AI, where we started from very high level principle, but then we went down to 7 requirements for an AI to be called trustworthy. And we said we would like Europe to only to to only facilitate and the deployment and the development of AI that follows and is compliant to these 7 requirements, which are again very aligned to the usual AI ethics. So you see them here: human agency oversight, robustness, privacy, transparency, fairness, well-being, and accountability. And this is very influential because even in the recent white paper that the European Commission wrote to envision the possible future regulations around AI, this framework around trustworthy AI of this high-level expert group is really central in their approach. The last one that I wanted to mention is very, very recent. It started only in 2020. It's called the Global Partnership on AI. And in this case, the partners are countries. So there are 15 countries that it started from actually 2 countries, France and Canada, and then it expanded to a total of 15 for now. And these 15 countries want to understand how to collaborate between countries at the international level to make sure to deliver AI according to some principles. And here the principles that were chosen by the Global Partnership on AI are the OECD recommendations on AI, and with the vision of the future that is given by the UN 17 Sustainable Development Goals, which you see here on the left-hand side. So here there are many, many experts that each country could nominate. Each country could nominate several experts. And these experts all together, they are partitioned into these 4 groups: responsible AI, data governance, and so on. I personally, I am in the responsible AI working group. And basically each working group works on that team, again, based on the principles, but with this idea of getting closer and closer to the UN Sustainable Goals, and with the angle of saying, what can these 15 and maybe more in the future countries do together to get closer to the UN Sustainable Development Goals. So the last part of my talk is just saying, well, as I said before, AI is not really done. You know, it has still has a lot of limitations. So, for example, AI still cannot learn causality information, but only correlations from data. And this is needed if we want to provide real explanations, because explanation is about this thing causes that, you know, tracing back the causes of a certain decision. So causality is really very important, and also allows to go from just predicting things to actually understanding how to intervene on the future, not just predict the future, but intervene. Say, if I change this, then I know that as a result, something else will be changed. And so I can intervene on the future rather than just predicting it. And also to learn with little data, as I said, and this is really important because we cannot continue adding data, resources, and computing power, and also robustness. So, and in this, for addressing this, in my current research project, I take a very multidisciplinary approach where we start from cognitive theories of human decision making, and especially from Daniel Kahneman theory of thinking fast and slow, or system 1 and system 2, that to understand, even though of course these are only theories, and Harari's theory as well, but they shed some light on what are the causes of our behavior and our capabilities that we would like, some of them we would like to bring into machines. So exploit what we know in this theory of human mind and behavior to adapt these causes of our capabilities and bring them into an AI system. And here, you know, so we have a very short paper that describes the main research question in this project, and it's on arXiv, and people are welcome to go and look at it. So as a summary, there's a lot of work to do to operationalize the principles, to understand how to start from the current limitations, but also to have in mind where we want to end up. So, for example, the UN Sustainable Development Goals, to define platforms, because we need this work around AI ethics to scale. So we cannot be have many ad hoc solutions, but it has to scale. To understand how to work with sharing data, best practices, sandboxes, make standards out of it, to identify also sustainable business models for using AI for good purposes, as well as to advance AI and overcome its current limitation, because this will help doing all the other things that I mentioned here. I just put some useful links, but everything that I talked about can be easily found on the web. So I stop the sharing and I welcome any questions.
Great. Thank you so much, Francesca. I'm going to give you a hand, even though not everybody can really do that because they're muted. So we go on from this to the next part of our program, which is a moderated discussion with Sonu Bedi, who's the head of the Ethics Institute, co-organizers of this event with the Institute for Security, Technology, and Society. And then after a few minutes of moderated discussion, we'll open the floor to questions. Folks in the audience are more than welcome to raise their hands or questions by Q&A at any point in time. Sonu, let me hand over to you and let you get this ball rolling, as you haven't spoken yet.
Okay, well, thanks, VS, and thank you, Francesca, Dr. Rossi. This was great. So let me ask you a question. Given that you sort of were talking about the way in which the stakeholders here, right? So do you have a sense that, do you see AI ethics as being pushed primarily by private stakeholders rather than public ones? And do you think that maybe that's a good thing? And do you think that governments are maybe slow to catch on here? You had suggested that in 2020 you had some countries together, but it looks like you at IBM and other private stakeholders are doing a lot. So how do you see the role of ethics and these principles in light of that?
Well, no, I have to say that, there's, yeah, the private company, yes, but also most governments around the world have their own national AI strategy that includes usually AI ethics issues and how to deal with AI ethics issues. So I mentioned the initiative taken by the European Commission, but I have to say that, all over the world there are national AI strategies. So this global partnership on AI that started in 2020 is a way for all these individual national strategies to say, how can we get together to actually collaborate at the international level? But even before that collaboration, each one of them had its own thinking about AI ethics. So, and as well as all the other stakeholders. So really, if you have a chance to go more deeply into that visual that was put together by the Harvard Principled AI project, you will see that some sets of principles come from companies, but some sets come from academia, some sets come from government, and from also multi-stakeholder environment. But having said that, in the partnership on AI that was started by companies and then included all the other civil society organizations, not governments, but civil society organizations, universities, and so on, it's clear that these different stakeholders have different point of views, of course. And in fact, in every project of the partnership on AI, where we try to reach a balance between for-profit and not-for-profit organizations, oftentimes there is disagreement. So we call it inside the partnership on AI, that is a very nice environment, because in some way we succeeded in creating this environment for what we call it productive disagreement. So even if there is disagreement, we think that we succeeded in exploiting the disagreement in a productive way. So for example, in these projects around the same table, you'll see companies that would never sit at the same table with ACLU, for example, but they are around the same table here, and they talk with each other and they express their difference of opinion, and then they get to deliver a document, a deliverable together. So there is an environment, there is the possibility of finding an environment where disagreement is actually exploited to be constructive.
Oh, good.
Francesca, I have a question. You gave this fascinating case study of a business opportunity that was presented to you at the IBM Ethics Board on a project that, the technology was cool. You really liked all aspects of the project, but you had concerns about the customer involved. And this sort of, brings me to the idea of, regulating not the technology, but the use of the technology. Much of AI is dual use in the sense that it can be used for both good and bad.
Yeah.
So, a good example is face recognition.
Yeah.
Right. So there are many, many very good uses of face recognition, but there are cases where face recognition has been used in repressive ways by various governments. So and there's also the concern that, a company like IBM is big and has the economics on its side that it can turn down such opportunities. But a startup might feel much more tempted to go for this opportunity if it's a business proposition, ignoring the ethics issues. So how would you have, how do you think about that kind of problem? How should the organizations, which are smaller and may find a business opportunity hard to resist, how do they sort of mitigate their risk and make these decisions?
Yeah, of course, I understand the issue, and but I have to say that more and more our clients ask, how do you deal with bias? Is that explainable or not? So more and more there is pressure from the clients to actually deliver something where you have some way of addressing these issues. Mm-hmm. And to go to your example of facial recognition, that's really, it's yeah, I agree completely that again it's very tied to this idea of again the uses are also important. So first of all, we have been very vocal about the fact that regulating AI should not be regulating research or regulating the technology itself, but regulating the high risk uses of AI. So defining what it means high risk, that can be already something complex, but once you define it, you regulate the uses that are high risk of AI and not AI itself, because as you say, if you regulate AI as a technology, then you lose all the other beneficial impact. But in terms of facial recognition, for example, IBM has made a decision of a few months ago. Our CEO wrote a letter to US Congress, but also declared, the whole company. So what we are not delivering anymore is general purpose facial recognition. What does it mean? Face recognition technology where we don't have control on the uses. That's going to be done. General purpose, it means you deliver this technology and then the client can decide in any way wants to use it. That's something that we don't deliver anymore. We deliver only after carefully vetting the use, the specific use that is going to be used for, as well as the client and all the other aspects, but not general purpose. So control on the use. And if the use is high risk, low risk, and whatever. So the use, the emphasis on the use, and what we call is, in terms of regulation, we call it precision regulation. So regulate high risk uses of a certain AI technology.
Could I follow up on that, Francesca? What would you characterize as sort of high risk uses? That's interesting because one immediate thought came to mind is that you could imagine the AI being used for public or governmental purposes like recidivism or risk assessment, but could also be used for private purposes. For instance, like you're on Facebook or something like that, and it generates an advertisement. So can you say a little bit more about what you mean? What would be characterized? What would be high risk? What would be low risk? I'd be curious. Yeah.
Yeah. I mean, of course, there is no clear, there is no clear definition, and that's why in the AI ethics board we try to give general guidelines, but then we say, well, come to the board and we analyze case by case basis, because at this point, I don't think that anybody has a clear definition of what is high risk, but definitely technology uses that are impacting on human rights, that are impacted on the things that we give for granted in our society, and we don't want the technology to be negatively impacting that. Then in each specific use case, then you may find a better way or a more precise way of defining what high risk is. But definitely things that have to go with mass surveillance or impacting human rights of any kind, that's something that definitely goes in the direction of being high risk.
Francesca, so I want to come to many of us on this call are researchers. And I think, we all welcome your statement that regulating on AI should not be something done, but regulating users of AI is something that certainly should be legislated or perhaps regulated. So, but how do we as researchers think about this? Because, if, for example, you took the example of GPT-3, so the research that's being done on GPT-3 could be used by all kinds of actors to influence the elections we have coming up in a couple of weeks, for example. They could generate tons of tweets, Instagram posts, images, methods for generative models of images and video could make our candidates say almost anything that an adversary might want them to say. So how do we sort of, how do we draw the line in terms of regulating research? I agree with you that research should not be regulated, but I have difficulty sort of grappling with,
Yeah, so another initiative that we are working on is called the responsible AI licenses. So this idea so we started to explore this idea for code released by research. By research teams. So when you release a code as a researcher or a research team, sometimes, when we publish paper, we attached to the paper there is the code, or sometimes whatever. So you release the code. In some sense, you are releasing the code in the general purpose sense, because then that code can be used by anybody in any way, right? So like the GPT-3 or whatever. So the idea here is to release this code from research with something which is very similar to an open source license, but it has clauses for usage restriction. So, and that you can say, okay, everybody can use it, but I put this restriction on the usage. And this restriction can be maybe related to the usual topics like fairness, or it can be related to human rights. It can be related to explainability. It can be related to whether you want this to be used in an autonomous way or not. So it helps understand whoever uses that piece of code that some usage is not appropriate. It's
Right.
not appropriate for that, and so it says, okay, I release this code, but with this usage restriction. Now we understand that as soon as you put user restriction, is not an open source license, so it's similar to an open source license, but we're still exploring that concept and trying to understand whether it makes sense, and possibly exploring it also together with the publishing entities, like
Right.
whether it's AAAI or Elsevier or everything, so to understand whether they want to support that idea, because again, we don't want to research to be restricted, but the usage things that comes out of research, maybe it makes sense that it has some usage restriction.
Thank you. So I think we've got a few questions in on the Q&A. Francesca, and maybe I'll take the first one and let Sonu take the second one. So I'll just read out the first one from Eugene Santos, who's a professor in the Thayer College of Engineering here. And Eugene asks, Francesca, thank you for a great talk. You mentioned IBM's path from ethics to guardrails, etc. What is yours and/or IBM's opinion on whether there is an existing regulatory or liability framework that can be adapted for AI systems meant to augment human decision-making? For example, FDA for AI-based health systems assumes a static AI. So.
Yeah, well, this is really work in progress, but it's true that most of the AI systems that are deployed right now are static, meaning that they don't evolve with data themselves. You can retrain them, of course, as a human being, but usually they don't actually evolve by themselves. So there is a little bit more control on how they change over time. But it's true that there is still not a definite, liability framework, especially for AI systems that work together with human beings, because at that point you have to evaluate, or you have to think about the team and not just the AI system by itself or the human being by itself. So that is still work in progress, and I hope that before we get to regulating things like that, we get to define best practices, standards, and other, sandboxes where we can try things in a safe place, in a safe environment. For example, IEEE has I think 14 or 15 startup working groups. It's called the P7000 series of standards around AI ethics, so that all the stakeholders can get together and define a standard of what it means to also human AI collaboration or bias or many other things. So it's still, I think it needs a lot of work, in my view, before we can define liability and regulatory frameworks.
I'll let Sonu read out the next question, but thank you.
Yeah, so the next question is from Harrison Fell, and the question is, when do you estimate that artificial general intelligence will be created? And if this technology is released, how concerned are you about the alignment problem?
Okay, so I was waiting for this question.
Okay, and maybe you can say something about the alignment problem so that people that are on this.
So the alignment problem is basically an expansion of what I said about fairness. Now, fairness is a value that we care about. We want decisions to be made in a way that do not discriminate. So we want AI to be behaving in a way that is aligned to this value of fairness. Now, value alignment is more general about any value, any principle that we want to be followed in a specific scenario. So fairness is just one of them, but in general, we want AI to not behave in a way that is undesired according to our values, whatever they are. Fairness is just one example. So that's value alignment, and of course, okay, then the other question is the obvious question that everybody asks. So when, especially the when is
yes.
artificial intelligence going to be happening? And I'm sorry, but I never respond to that question. And first of all, every year, every 2 years, the Future of Life Institute has a conference where many different experts of AI, they are being asked this question. And every year there is this curve of, between 1, 2, whatever, 100 years. And there is always the same curve with a peak at 20 years. But this has been for decades. Okay, so the peak is always at 20 years. So of course it's not, but the tails are very thick. So that means that experts don't know, basically. Right? We don't know. And although I agree that I know that there are some experts that will give you a number, will give you a date, but I cannot give you a date because, as I shown, there are so many challenges that needs to be addressed and solved before we get to the kind of AI that can be called general, in the sense that can go horizontally from one problem solving to another, learn here and use there, and then being able to do something similar to what we do in human beings, and even more because it has more computing power and more data and so on. So that I don't know, because then we think that there are these challenges, and once these challenges are done, but maybe once they are addressed, maybe we will see other challenges. So I don't know exactly see how it will go. But that's not my focus really, because the value alignment problem is important right now. It's not important when AGI will be with us. It's important right now that the AI that we deliver, even if it's very focused and narrow, that it is aligned to whatever values are important in that environment. So to me, the more we advance AI, the more we also have to advance our capability of making it aligned with our values. And so in my view, this incremental approach of augmenting the capabilities and the value alignment also of AI can help us get to more advanced versions of AI that are also value aligned.
So Francesca, can I follow up on that from an ethical point of view? Do you think that that strategy of slowly moving so that the alignment doesn't get ahead of the technology, you see that as a you know, that's not, I mean, that's, you would say that's a good thing, and that's, is that what you're suggesting? Whereas that we don't want the AGI to go beyond to sort of get ahead of us? Is that a fair characterization, what you're saying?
I don't, well, well, what's the alternative? The alternative is just to advance AI and don't care about value alignment, which I don't think is a very good idea. So there is no way to advance value alignment without knowing where AI is. So to me, that's the only viable alternative, unless we want to just advance AI without thinking about the values. But I think that more and more, again, the environment, the clients, the governments, and so on, the whole ecosystem understands that we need to care about augmenting the capabilities of AI, but at the same time, making sure that follows our values. And some people sometimes think that doing that will slow the innovation, right? Because they say, oh, if I have to think about all these values, then I'm going to be slow in advancing AI. But I personally don't think so, because of course it depends on how do you define innovation. To me, the only innovation that I want to see is the innovation where there is value alignment. So a philosopher friend of mine, Patrick Link, he once told me a very nice analogy that in traffic, we have a lot of rules, traffic lights, the precedent sign and so on. And of course, if we didn't have all these rules, probably we'll go much faster. But we would, but we actually would be very afraid of, because we wouldn't know, is another car coming? So without rules, actually, we would not go faster, but we would go slower because of all this uncertainty. With our rules instead that we have for traffic light, we can go faster and then follow the rules. So in some sense, traffic lights are like allowing enablers for the right kind of innovation rather than slowing innovation.
They're advancing the technology in a way,
Francesca, we have a question hand raised from Dongkai Chen. So I'm going to allow him to ask you the question verbally. So Dongkai, I just unmuted you. So please go ahead.
Okay, can you hear me?
Yes.
Yes, please go ahead.
Okay, sorry. So my question is that in the current AI experiential models, actually different people focus on different parts, and actually most of the works starting from the how to explain the current model. But I think that there are not too much works focused on how to interpret the data set, based on the data set and
how to interpret the what?
Interpret those. I don't know how to describe this.
You mean the predictive how to explain or interpret the predictive models, Dongkai?
Yes. I mean, most of work just to try to interpret the model, but I mean, the success of the current. I'm sure I'm a little lost in my question.
you're saying that most work goes into interpreting or explaining the models, but
Yeah, yes.
what did you want to know? I mean, what were you asking?
Yeah, okay, another easy way is that, do you think that this kind of explanation can help this community to understand the deep learning, or to push the understanding of deep learning to help the community to understand this kind of work? Is this way is a good way to go?
Yeah. So explainability is definitely very, very important. Because again, as I said, if it's just a black box that people don't understand how it gets to the decisions, then they would not adopt that technology, or they would not trust the recommendations. So definitely explainability is very, of course, when you explainability is important in some scenarios. Of course, if you have a real-time system that needs to make a lot of decisions, it's going to be an explanation for each one of the decision. But so you have to put together another thing. But in a human-machine interaction, I think the explainability is important for that human being to really understand. But there are some situations where you may not want an explanation all the time, or maybe it's not really important to have an explanation. So for example, you have a recommendation for a book to buy online. Maybe you wouldn't care about getting an explanation, even if you find this recommendation kind of strange, then okay, fine. But if you want a doctor to listen to a recommendation about what's the best therapy to use for a patient, then I assume that doctor wants an explanation before actually adopting that therapy.
Thanks. But in reality, like if we use some interpretive mode framework to do some explanation on different models, and maybe like we use some ResNet model or some other VGNet model, and to explain why they predict an image class in like predict this image belongs to a children or something like this, and because we are using different models, and the interpreted framework will give us different explanation based on these two models. So how do you choose the which model you want to use in the product in the industry?
Yeah, the explainability space is very complex. First of all, because different models, because even for the same model, you can generate different explanations for the same decisions, depending on the techniques that you use, and also because the recipient of the explanation can be very different. Can be, to mention the case of that, it can be the doctor, the patient, the developer. You can use explanation as a debugging tool, for example. So you need to be able to produce different explanations, but also, as you say, different models or different techniques for the same model can produce different explanations. So it's still a lot of research being done. But I think that's why, these open source toolkits that we released around explainability is very important, because the whole research community needs to get together, understand what's the best way to deal with these explanations. How do you choose between two different explanations for the same model, and so on. So still a lot of work to be done.
So I think, Donkai, thank you for your question and its follow-up. I think we're just a minute past 4, and I'm going to use this opportunity to once again thank Francesca for a wonderful talk. I think you've had really brought up a number of very, very important issues that even those of us who've been thinking about AI and ethics have not necessarily thought through as well as you and your colleagues at IBM have. So again, kudos to you and your team at IBM, as well as to the various ethics groups thinking about it, and thank you so much. So please join me in thanking Francesca. Again, the only guys who can clap and be heard are Sonu and me, so I'll just clap again.
No, we'll do it. Thank you.
Thank you.
But thank you so much. And Francesca, I'll follow up with an email.
Sure.
well. But again, thank you for so much for taking the time and being.
Thank you. It
Thanks,
was a pleasure.
Francesca.
Thank you. Bye-bye.
Bye.